Welcome back to a course on calculus in which we are dealing about differentiation. We have seen the definition of a differentiation and a theorem based on derivatives. That is, differentiable functions are continuous, whereas the converse need not be true. And we have seen examples on these cases. In this lecture, we are going to see the laws of differentiation. So, what do we mean by the laws of differentiation? Are in the usual notations that are in the usual terms that we used, we are going to see about the derivative of algebra of functions. Let us state this as a theorem. Okay, suppose f and g are defined on the closed interval a comma b, and they are differentiable too, right? So they are differentiable at a point x in this interval AB, then f addition and subtraction, fg and f upon g, this is okay, let me write this way. F upon g are also differentiable at x. Okay, in particular, f plus or minus g prime of x is going to be f prime of x plus g prime of x. If it is plus, it is going to be minus. If it is minus here, then fg whole prime of x is g of x into f prime of x plus f of x into g prime of x. Okay, then f upon g whole prime of x is going to be g of x f prime of x minus f of x g prime of x upon g of x squared. Here this is going to be true only if g of x is not 0. Let us prove these things. Given f and g are differentiable, therefore the limit t approaches x, f of t minus f of x upon t minus x is going f prime of x, and limit t approaches x, g of t minus g of x upon t minus x is g prime of x. These two exist. Okay, consider what f plus g of t minus f plus g of x upon t minus x. Using the algebra of functions, we shall write this as f of t plus g of t minus f of x minus g of x upon t minus x, and this shall be written as f of t minus f of x upon t minus x plus g of t minus g of x upon t minus x. So when we take limit t approaches x to the function f plus g of t minus f plus g of x upon t minus x, it is going to be limit t approaches x, f of t minus f of x upon t minus x plus limit t approaches x, g of t minus g of x upon t minus x, and this happens to be f prime of x and this happens to be g prime of x. In a similar way, we shall prove we can prove for the difference case, that is limit t approaches x f minus g of t minus f minus g of x upon t minus x is f prime of x minus g prime of x, right? We have proved for the sum and difference case. Now let us prove for the product case, okay, for which let us consider fg of t minus fg of x upon t minus x. Now let us write this as, that is we are applying the algebra of functions f of t g of t minus f of x g of x upon t minus x, and here you notice that t is combined, x is combined. Now it is up to you to introduce, that is add and subtract a term which consists of t and x. So it is up to us to decide what to be added. I am adding f of x g of t and subtracting the same. Without altering the values of these functions, I am doing this. You may do it in the other way, that is f of t g of x, that also can be done, right? I am taking like this, from the first two terms I am taking g of t out, so I will be left with f of t minus f of x, and from the second two terms I am taking f of x outside, so g of t minus g of x and everything upon t minus x. This one I am writing as t minus x, t minus x. I have split these things, right? Now I am taking limit t approaches x fg of t minus fg of x upon t minus x. So this is going to be, I am directly applying the algebra of limits, so this is going to be simply g of t times limit t approaches x, sorry, g of t is done though, so f of t minus f of x upon t minus x plus limit t approaches x f of x times of limit t approaches x g of t minus g of x upon t minus x, right? Since f and g are differentiable, which means they are continuous at all those points in which the function is differentiable. So this function g is given to be differentiable in the hypothesis, right? So these functions are differentiable at the point x, which means the function has to be continuous at the point x as well. Using that idea, we shall write the first term. Just a minute. This quantity, this quantity becomes simply g of x, and this is f prime of x. This is independent of t, so we simply have the same thing, and this is going to be g prime of x. Okay, finally what we have done is that fg prime of x is g of x f prime of x plus f of x g prime of x. If you have taken, suppose if you have added and subtracted f of t g of x plus f of t g of x, if you have done it, what you could have got is that from the first two terms you might have taken f of t outside, so you will be left with g of t minus g of x, and from the second two terms you can take here g of x outside, so f of t minus f of x. This is what you might have got, so this is upon t minus x. Here we were in a need to make use of the continuity of g. In this case we might be in a need to make use of the continuity of f, right? This would be the only difference. The result will not affect at all. So it is up to us to add and subtract a quantity, right? Make sure that it is t is combined already and x is combined already, so we'll have to introduce some term which is a combination of both, right? So hope you get the idea. I'm not writing many things here. When suppose if you are preparing these things for your examination, make sure that you are including some steps, right? You will have to state why this becomes simply g of x. This is because of g is continuous at x. Okay, here this is independent of t, that is why we get the same thing. So you must be clear when you are writing this for your semester end examinations, right? Now let us do the third part of this theorem. So here let us consider f upon g of t minus f upon g of x upon t minus x. So this shall be written as f of t upon g of t minus f of x upon g of x upon t minus x. So when you take LCM in the numerator, you will have f of t g of x minus f of x g of t upon g of t g of x, everything upon t minus x, right? So from this I am taking this g of t g of x outside, and I will be left with f of t of what f of t g of x minus f of x g of t upon t minus x. Here also we will have to add and subtract a quantity. This is 1 upon g of t g of x. I am adding and subtracting f of x g of x. Why can't we do f of t g of t? You may get that doubt. If you do so, then anyway we are going to make the t approaches x, and since f and g are continuous, the product is also going to be continuous, and whenever the function is continuous, limit as t approaches x of f of t is going to be simply f of x. Even if you do f of t, that will turn to f of x anyways. That is why we have directly given f of x g of x, right? So here let us do the splittings. So from the first two terms, we may take g of x outside. So it's going to be f of t minus f of x upon t minus x. From the second two terms, we shall take f of x outside. So it's going to be g of x minus g of t. First, I would like to write t. That is why I am taking minus outside. G of t minus g of x upon t minus x. What is the, some of you may have a doubt that what is the need of writing a t term as a first term. It is due to the reason that if you write t term as the first term, then only you can do the process of limit. When you take the limit, then only you will get that to be the derivative value, right? Now we will have to take the limit. So here itself, let me do limit x approaches t f upon g of t minus f upon g of x upon t minus x. This is same as that of the limit of this thing, sorry, t approaches x, right? So t approaches x. Okay, so in the next step, it is limit t approaches x 1 upon g of t g of x, and then limit t approaches x g of x f of t minus f of x upon t minus x minus of limit t approaches x f of x g of t minus g of x upon t minus x. So here we are imposing the condition that, okay, since g of x is non-zero, this is not becoming infinity. This is going to be a finite value. The limit has to be a finite value so that we can say the limit exists, right? So this quantity is going to be simply 1 upon g of x whole squared, right? From the first term, it is independent of t, that so it remains g of x as it is, and this becomes f prime of x, and minus this remains as it is, and this becomes g prime of x. So finally what we have is that f upon g prime of x is g of x f prime of x minus f of x g prime of x upon g of x the whole square, right? Hope I don't need to give you the problems to make use of these properties. Hope we people have studied these things in our schooling itself. Here I have given you how we got these things. Let us now see some standard differentiable functions. In the limits and continuity concept also, we have seen some standard continuous functions. Here I am not going to prove the differentiability of these functions, just I am going to state these things. Okay, the identity mapping, the identity function, that is f of x is x. It is differentiable everywhere with the derivative f prime of x to be 1 for all x in the whatsoever domain we take. Okay, so if I take simply d, this means any possible domain. Okay, the next one is if I take any constant function, that is f of x is equal to c for all x. It is also differentiable everywhere with the derivative f of x is 0, right? And the next is polynomial functions. So let me denote polynomial functions as p of x. This is a0 plus a1x plus a2x squared a3x cube, and it goes till an x bar n, where these are this n is some positive integer and an is non-zero. Polynomials are also differentiable functions. Okay, I leave these things as an exercise to you people to check whether these are true or not. Rational functions, r of x. Let us denote rational functions as r of x. This is defined as p of x upon q of x, where p of x and q of x are polynomials. Okay. Thank you.